All right, let's talk about Docker. It's one of those technologies that has totally changed the game for building and running software. And it all started by solving a problem that's probably as old as software itself, summed up by 5 words every developer absolutely dreads.
Ah yes, it works on my machine. If you're a developer, you've definitely said it. If you work anywhere near developers, you've for sure heard it. This one phrase is a symptom of a really deep, expensive problem right at the heart of getting software out the door. But here's the secret. When a developer says this, it's almost never because the code is bad. Nope. The real villain is the massive, invisible chasm between their computer and the production server where the application actually needs to run. All these tiny little differences, they just create total chaos.
And this is what that chaos looks like. People call it the matrix from hell for a reason. You've got different operating systems, libraries that clash with each other, slightly different versions of Python or Node.js. It's this nightmare combination where everything has to be just right. Trying to manage this by hand is slow, it's full of errors, and it creates so much tension between the dev and ops teams.
So, to fix this, we needed a totally new way of thinking about the problem. What if, instead of just trying to ship the code itself, we could package up the code and its entire environment into one standard predictable box?
And the big idea here actually comes from a totally different world: physical shipping. Before those standard metal shipping containers, global trade was a mess. But that one standard box changed everything. Docker does the exact same thing, but for our code.
And this process is called containerization. It really is the software version of that shipping container. You take your application and you bundle it with everything it needs to run, all the libraries, all the config files, the whole shebang, into one neat, isolated package. That package is going to work the same no matter where you put it.
Now, to really appreciate how Docker pulls this off, it helps to compare it to the technology that came before it, something called virtual machines, or VMs, because the difference between them is absolutely fundamental.
So here's the key. A virtual machine simulates an entire computer, the hardware, everything. That means every single VM has to run its own full-blown guest operating system. It's super heavy. Docker, on the other hand, is way more clever. It does what's called OS-level virtualization. Basically, all the containers running on a machine share the host machine's core operating system, its kernel.
And that one architectural difference, it leads to these incredible benefits. Just look at the comparison. Containers are tiny. We're talking megabytes instead of gigabytes. They start up in milliseconds, not minutes. And because you're not running a whole extra operating system, their performance is pretty much native speed. You can cram way more containers onto one server, which is a massive win for efficiency and for your wallet.
Okay, so this sounds awesome, but how do you actually use it? Well, the day-to-day workflow is beautifully simple. It just boils down to 3 main steps. First, you write a Docker file. Just think of it like a recipe or a blueprint. Then, you tell Docker to build that file, and it creates a Docker image. That's your template, your final packaged-up application. And finally, you tell Docker to run that image, and that creates a container, the actual live running version of your app. So, it's blueprint to template to live app. That's the flow.
This super simple workflow has had a truly massive impact. It's completely changed the way modern software gets delivered, and it lets companies move way faster and with a lot more confidence.
It really all comes down to this one powerful promise. The Docker image becomes this single, unchangeable artifact that you build just one time. And then that exact same image flows all the way through your testing, staging, and finally into production. The works on my machine problem, it just vanishes.
And the results in the real world are just staggering. Take the Warehouse Group. They saved an estimated 52,000 developer hours in less than a year. That's not a small tweak. That is a complete game changer for their productivity.
Well, look at this example from a company called Atakama. By switching to Docker, they started deploying new features 75% faster, and at the same time, they were able to reduce their number of servers by 40%. So they're shipping better software, faster, and it's costing them less. That's the dream, right?
Okay, so Docker is fantastic for getting that consistency from a single laptop to a single server. But what happens when you need to go big? What about when you're running thousands of containers to serve millions of people around the world?
Yeah, this is the challenge of scale. How do you manage all of that? How do you balance the traffic, automatically recover if a server goes down, or scale up your app when you get a huge spike in users? Doing that by hand would be completely impossible.
And that's where container orchestration comes into the picture. An orchestrator is basically the conductor for your whole container orchestra. It's a system that automates all that crazy complexity. It figures out where to place containers, it heals them if they break, and it scales them up and down for you.
In this world, you'll hear two main names. There's Docker Swarm, which is built right into Docker and is really simple and easy to get started with. But the undisputed king, the industry standard for big, serious production systems, is Kubernetes, also known as K8s. It's an incredibly powerful platform that pretty much runs the modern internet.
When you really step back and look at the big picture, Docker's most important contribution might just be this idea of decoupling. It severs the dependencies. It separates your app from the operating system, it separates the developer's laptop from the production server, and it even separates the different parts of a complex application from each other.
And that decoupling is everything. It's what makes modern software possible. It's what gives our apps the portability to run on any cloud, the scalability to handle huge amounts of traffic, and the resilience to bounce back from failures without anyone noticing.
Which brings us to a really exciting final thought. By making the application a truly portable, self-contained thing, Docker has basically laid a new foundation for us to build on. So the question we're left with is, what comes next? What kind of amazing new software will we build now that this is possible?